I'm Sonia Hashim.
And I'm Jingyi.
Today we're presenting work with Jennifer Jacobs on what visual artists can teach us about software development. Software is closely integrated with art production, but developing software for artists is challenging. By analyzing how artists use and develop software, we identified opportunities for end-user software development to map to creativity support tools. We interviewed 13 professional artists. We then analyzed interview data to surface themes such as why artists choose to build software and how software development shaped their practice. We focused on expert practitioners and visual artists across diverse domains, such as painting and interaction design. Artists were motivated to build software for multiple reasons. Artists built software for functional applications, like adding interactivity to artwork. Artists also use software for creative growth, such as coding their own interfaces to support specific forms of exploration or creative constraint. Lastly, artists develop software to establish technical authority when working with other artists or software developers. Next, we share some implications of our findings for HCI systems researchers. For instance, creativity support tools that prioritize black box automation and high-level abstractions can prevent artists from developing unique processes and outcomes. There's a trend in creativity support tool research to build tools for novices. To lower barriers to entry, many systems rely on automating processes and abstracting data to generate artwork. However, we found artists value granular control over the ways their materials are used, their data, and the ways they are transformed through processes to develop bespoke and sophisticated outcomes. As one example, Molly, an artist, used a vinyl cutter to cut parts for a sculpture. The out-of-the-box software was incompatible with her designs based on line drawings. In order to cut her designs and maintain their stylistic integrity, Molly wrote her own cutting algorithm that could handle intersections and interpret Bezier curves with thickness. She needed to write her own algorithm to reflect, 1, her technical understanding of the vinyl cutter functionality, and 2, her need to transform her line drawings into a format aligned with that functionality while retaining the intended stylistic quality.
Another theme of our research highlighted the ways artists who rely primarily on digital tools frequently switch back and forth between physical and digital materials throughout their processes. For example, Ben alternated between painting on a tablet, where it was easier to pick and preview colors, and painting with oil paints, where the materiality of the paint that could not be replicated in software mattered for the final look. Michael used digital fabrication techniques to think through different physical representations of a vector graphic he made, saying, I can extrude this. I can laser cut it 15 times and laminate it. I'm going to find opportunities past the computer. Due to these flexible workflows, we see opportunities for designing digital software that accommodate manual input and physical materials. These systems could support nonlinear workflows such that the output of any single stage can be the input of another. For example, in contrast to the usual linear digital fabrication workflow, we can imagine a software environment where a single interface lets artists author graphics, modify manual input parameters, and program CNC machine behavior. While our previous 2 takeaways provided guidelines for system design and engineering, we now discuss the larger socio-technical context of end-user programming for artists. From our interviews, we have seen many examples of how and why artists are creating their own software. Artists have a deep domain knowledge of their craft, choose tools based on their constraints, and feel a constant need to innovate. Chris described how there's this weird race to find the new edges of the new box every time a software update is pushed out, constantly finding the new aesthetics, or what are the aesthetics that everyone is sort of working in, but that you need to push just beyond. As the goal of end-user programming research is to also enable users to push beyond what current tools allow, we argue that visual artists who treat this pushing beyond as an integral part of their practice are ideal technical collaborators. Their experiences adapting software to meet their needs can inform the design of low-level domain-specific program representations, and their understanding of creative communities can help researchers grow interdisciplinary communities who extend software use in diverse ways. However, collaborations are a two-way street. We also advocate for HCI researchers to consider as potential contributions the kinds of achievements that are valued in an art career, such as making polished artifacts with systems over time and releasing technologies back to the creative communities. We hope that these forms of community engagement strengthen the depth of systems research and increase the impact it has outside the academy.
Thanks for watching our presentation. We hope you'll read the paper and reach out.
Thank you.